So welcome back. Today we are discussing about one of the most important topic in water resource engineering, life of a reservoir. Okay, as you all know, we are constructing a dam for the purpose of getting a reservoir. Okay, and reservoir is just a big pond so that we can store a very large amount of water through a whole year, so that you can use water from this reservoir for a number of reasons: irrigations, electricity production, tourism, domestic purposes. Okay, so all these things you need to store all the amount of water for a whole year till the next rain comes. That's why we are constructing dams. Okay, we know that. So reservoir is the pond generated by dams so that you can store water for a year. Okay, so how does a reservoir dies? So what is the main thing that determines the life of reservoir? That is called sedimentation. We know what is sedimentation is. Sedimentation is the gradual accumulation of silt particles, silt or soil particles in the reservoir. Okay, so if this is a very vague representation of a reservoir, there will be a bottom sluice pipe or vacating pipe in dams. Below that portion, for example this portion, and this portion is called dead zone or dead storage, where we are not taking considering the storage of water as the storage of reservoir. We will not be taking these areas of waters for our purpose, whatever purpose we are using it for. Okay, so this is allotted so that sedimentation can be accumulated. As per the data, there will be sedimentation flowing in from the catchment area into the dam and will be stored in this zone. There will be soils accumulated in this area. Okay, as the year goes by, this dead storage will be accumulating sedimentation. Okay, so as this sedimentation increases as the years goes by, if this sedimentation increases one layer by one layer by one layer, at the end of a particular time period, this initial 100% storage of reservoir, initially when the reservoir is commissioned, storage will be 100%. When the storage reduces to 20% only, we consider it as dead reservoir. Okay, so when the storage capacity of reservoir decreases from 100 to 20, when it reaches effective storage reaches 20%, we consider it as dead. So the time period or number of years required to get this 80% area of effective storage to be filled by sedimentation is called as life of reservoir. Okay, so life of reservoir is the number of years that 80% of effective storage of a reservoir is getting filled to reach 20% of effective storage. Okay, so that is the brief point on how does a reservoir die, or how is the life of reservoir can be calculated roughly. Okay, so we are getting back to sedimentation. So sedimentation is Sedimentation is the accumulation of silt or soil particles in the reservoir, in this case in the reservoir, okay, and there are of two kinds, okay. So if this is in plan, if this is the reservoir, if dam is here, the catchment area will be like this. This will be a big area like 1000 kilometer square, and this will be the pond or the reservoir, and this will be the dam, suppose, okay. So when precipitation occurs, water will be flowing in like this, okay. So when the water flows in after precipitation, this water will be bringing some portion of soil and silt with it, okay. Silt particles will be there. It will be in two ways. The silt particles are transported by sedimentation to reservoir in two ways. First one, bed load, and second one, suspended load. Okay. So this is two ways by which sedimentation can be occurred to reservoir. This is very simple. Bed load is the load of silt that is transported by the rainwater through the bed. If suppose this is the cross section of area and this is the reservoir, if the silt particles are only moving through the bed itself, when the rainwater flows like this, if the bigger particles are rolling through the soil or sliding through the soil, it is called as bed load, okay. As you know, if you will recognize this, if this is soil particles, you will have some designs like this in the soil after a rain. If you observe in any soil, after rain there will be designs like this when soil water is moving in this direction, flowing in this direction. So that movement of bed soil is called bed load, okay. And suspended soil is just the flowing of silt particles suspended in the flowing water. If this is the water level and the water carries suspended soil particles or silt particles with it, we call it as suspended load, okay. I hope you understand. Silt can be transported to the reservoir in two ways, either through the bed like this, in rolling through the soil itself or surface of ground itself, or by suspended particles that are suspended in the water flowing into the reservoir. Bed load will be very less, 1/10th or 1/9th of suspended load, okay. So that is about sedimentation, types of sedimentation that can occur. And what are the main factors that affect sedimentation? And the factors are nature of soil in catchment area, catchment area is the big area from which water flows into the reservoir. Now, how does nature of soil affect sediment storage or sediment accumulation? If suppose the base soil particles through which the rainwater is flowing through is a very light silt particles, sedimentation will be more, okay. If you get the point, it's very simple. If the soil particles in here are too fine and too silty and light soil particles, it will be very easily transported or sedimented. Very easily it will be reaching reservoirs. And if the soil particles are very heavy, or most of the soil particles or most of the area is of rocky surface, through rocks the water is running, there will be very less sedimentation. Lesser soil particles will be transported by water. So nature of soil is a big part. And second one, B, topography. Topography of of catchment area. Topography means if suppose you are having a very steep hill, then more and more, as with more and more rainfall, more soil will be flowing downwards, hence sedimentation will be more. If the slope is less, suppose this is, there will be lesser speed of flowing water through this lesser slope. So hence lesser soil particles will be carried by the water and hence lesser sedimentation. Okay, so that is topography. Okay, then third one, vegetation cover. Vegetation cover, it's very obvious. If there is vegetation cover, if there is grass, trees and everything, erosion will be very less. So if there is vegetation cover, sedimentation will be very less. If the vegetation cover is not present, soil will be flowing very easily with the water. Okay, unlike if there are trees, the trees roots will be keeping the soil with themselves. If there is grass, they will be holding the soil without flowing. Okay, so if there is no presence of vegetation cover in the catchment area, there will be lesser sedimentation. If not, there will be higher sedimentation. Okay, and the last one, intensity of rainfall. Intensity of rainfall is also very obvious. If suppose this is not about the duration of rainfall or the total amount of rainfall, it is just about intensity of rainfall. Okay, so point is, if only for a 5 minutes heavy rain is happening, many more soil will be dislodged from its original location and will be traveling with the water. Okay, and that will be more than compared to if suppose 5 hours of rain is happening, but the rain intensity is very less, that is very small intensity, is just tiny droplets are falling into the ground, so it will not be disturbing the soil strata or structure. It will be just get either infiltrated downwards or it will be flowing very slowly. Okay, so if intensity is very high, there will be very high sedimentation, and if intensity is small, there will be lesser sedimentation. Okay, so these are the factors that decide on sedimentation of reservoir sedimentation, and these are the two types by which these sedimental particles can be transported. Okay, and we are getting into next topic, density currents. So density currents are a very common name that is referred in hydrology and also in geotechnics, and it is just the interaction of two fluids with slightly different density. Okay, so in this case, in reservoirs there will be clear water in the storage, the main storage nearer to down. There will be clear water stored in, that has been stored a month ago or 2 months ago, and when a rain happens, the water will be flowing in. Okay, and this inflow water will be having sediments than the clear water. The clear water will be too clear, there will be no sediments in it, no soil particles in it, but the inflow water will be having high soil load or high sediment load. Okay, so it will be like a colloidal fluid, and it will be having a higher density, obviously higher density than clear water that has been stored in the reservoir. So this higher density clear water or silt colloidal particle fluid will be flowing below to the clear water like this, where the clear water will be contained into this space. Okay, so this high density silt carrying higher density fluid will be flowing under this clear water, and many of the colloidal particles will be, or silt particles will be stored in here. Okay, that is settlement. Settlement of silt. So the flowing of higher density sediment loaded rainwater below the clear water that had been earlierly stored in the reservoir is called density currents. Okay, I hope the term is clear. If you have the figure and just the explanation of these 3 points, it's very clear to understand. Okay, so moving on. So moving back to our main topic after sedimentation and density currents, life of reservoir. As I said earlier, when the initial storage decreases from 100 to 20%, we consider the reservoir as dead. Okay, and for this we have 2 terms that yet to be addressed. Okay, and they are trap efficiency and capacity inflow by inflow ratio. Okay, so as we are going on to calculation of life of reservoir, trap efficiency is of prime importance. Trap efficiency, please have attention. Trap efficiency is a property that is carried by the water into the reservoir when it is the percentage of trapping sediment in reservoir. Okay, so trap efficiency is the percentage of trapped sediment compared to the original load of sediments in the flowing inflow water. Okay, so suppose trap efficiency is 90%, for example. If trap efficiency is 90%, that means out of 100, suppose 100 kilogram of sediment is carried by a particular amount of water, and if trap efficiency denoted like this, if 100 kilogram of sediment is carried by an amount of water, rainfall water, okay, 100 kilogram of sediment, soil content is carried by some amount of rainfall water, precipitated water. If trap efficiency of that particular reservoir is 90%, then only 90 kilogram will be trapped in the reservoir and 10 kilogram will be going out of reservoir. Out of the reservoir means that 10 kilogram will be taken up by the use of any purpose. Maybe that 10 kilogram of load will be going through the water when water is taken out for irrigation. Maybe there may be sediment load when water is taken for hydroelectric power projects. Okay, so if trap efficiency is 90%, only 90% of total load will be deposited in the reservoir and the rest will be going out. Okay, so that is the key point. And trap efficiency is determined by a single ratio that is called as capacity by inflow ratio. Okay, so by calculating capacity by inflow, you can get standard trap efficiency value like 90%, 92%, 96%, etc. Okay, and with that trap efficiency we will be calculating, after some procedures we will be calculating life of reservoir. Okay, so I hope you understood these 2 things. Okay, capacity by inflow is just if the capacity, this is the capacity of reservoir and inflow is volume of water coming into reservoir in a year. Okay, so capacity will be the storage of water. If suppose 1000 hectare meter is the capacity of a particular reservoir, and 500 hectare meter water is coming in from outside from the catchment area to the reservoir every year. That means 1000 by 500, 2 will be capacity inflow ratio. That is as simple as that. You get the capacity of reservoir and inflow of water that is coming into the reservoir every year, and you take the ratio, and from that ratio you will be calculating trap efficiency. Okay, I hope it's clear. Then in the next video we will move on to problem solving of life of reservoir or calculation of life of reservoir. Thank you.